What is up? All right, so today I'm going to talk a little bit about, I got to ask about the Pi Network. Is somebody? I guess I should talk about who am I as far as crypto is concerned, if this gets watched. So I typically stream, like, I don't know, before I was streaming games, and I did that just a little bit, not very popular. I made a couple of videos that have had a few views about games, and I decided I'd start streaming code. But I used to do cryptocurrency stuff, and I mean by that I mean I used to mine Doge. I mined over 1 million Dogecoin, so that's sort of my credibility under my house. So I had miners with GPUs. So I just basically got these milk crates, and I built 5 rigs, and I just had a regular, like, I just bought okay motherboards, and then I had 4 cards in each crate, 4 GPUs. They were R290s, I think. I still have a bunch of them. It's kind of ridiculous how many video cards I have, but they're not really great for mining anymore because the video cards are kind of slow now. But back in the day, those were the fastest that you could buy, and I think I paid somewhere between like $500 and $700 each for them, and I ended up mining millions of Doge. I didn't really mine anything else. I tried a couple other things, but nothing serious, and just ended up mining Dogecoin. And so I was looking at this Pi network, and what I'm going to talk about real quick is proof of work. I guess I should also mention that I occasionally volunteered for the SF Bitcoin meetup, and I know people in the space. For what it's worth, I haven't been in the space for a really long time, so I'm nobody. So proof of work is this idea of doing something with I guess I probably don't want to search for that on the internet anymore. What I really want to do is I just want to look at an image of a spreadsheet, sort of, if we can. And proof of work is just a way to solve a common shared puzzle, what's called a nonce, while at the same time verifying transactions on a chain. And most blockchains have a common data structure to them, and this is called a acyclic directed graph. I even spelled it wrong. Right. So this is an acyclic directed acyclic graph, a DAG, a DAG as we used to say. When I was in the space, we'd say DAG, and I say in the space, I was hanging out with Bitcoiners. So early Bitcoiners, I just briefly hung out with like the largest miner at the time, running mining rigs in China. They'd come to the meetup occasionally. I hung out with the early Lightning people, the people that designed Lightning. So I was kind of in the room when the idea of Lightning happened. Kind of. I didn't write the paper or anything. I had nothing to do with coding it or writing the paper or anything. And so, but I've thought it's given me the opportunity to think a lot about this technology. And so, this idea of a directed acyclic graph, acyclic, I guess is the way you could think about it. So in other words, it doesn't come back to itself. So if you started a node, if you're in a node theory, or like the idea of nodes, there's a lot, like in programming, you can have like a linked list. So items linking to other things, like in C, for example, you can have linked lists. But anyway, so you can have linked list in any type of programming language, that type of data structure. But in the acyclic version, you don't come back in a DAG. You don't come back to an entry again. You can jump over an entry. So this one can link to something that's further down the chain, and this is why we call it the chain. That's why we call it a block chain. The block is a data structure that gets baked and is preserved, and inside of the block is a chain. And these things are chained together, so they point at each other. And in Bitcoin, for example, if you have a value in here, that's why I pulled up the spreadsheet. It's basically a spreadsheet. So you'll have like an entry, and maybe this is a bad example, but if I can get something that maybe is listing out, items, I don't know. Probably not going to find a great one, but let's pretend it's this one. So we got these symbols. So let's pretend the symbol is a Bitcoin address. And then you have some price in here, and maybe on, this particular address, you have a price, but then you have something withdrawn from it. And when you have a withdrawal, this would be, you would have this graph built, and you'd say, I moved this value that was in A, so like 300, I moved it to D. And then I moved 400 to C and 800 to B and then 20 to E. And then there's nothing left in here. So if we were go to look at the spreadsheet, there'd be a zero balance there. And then what would happen is somebody would pick up that data structure. It's distributed amongst all of the what we call miners and full nodes. So a full node is something that is it's like a client or a wallet, if you've heard that term, that has all of the transactions in it. And the Bitcoin full chain is probably monstrous by now. It's many gigabytes, if not more. I have no idea. I don't think it's a terabyte yet, but we could look. It's probably not a terabyte. But it's a pretty big data structure. So it takes a while to download it. And it could be big, but bigger than I think it is. And so I haven't looked in years. And so the idea would be that the way that you verify that, if we could just distribute the DAG or the graph or the chain, or the block, I'm sorry, if we could distribute that block, the block has all of the other transactions in it that came in a previous block. So if A got transferred to D, then we could just take a picture of that, and that's a block. And then we distribute it to everybody, and then they secure it. Now we'll talk about how they secure it here in just a second. We're going to get back to the proof of work. But the idea would be that then in a subsequent block, A would transfer something to C, or maybe a better example would be A transfers to B, D, and C in one block, and then it transfers to E in another block. So we could just draw a line here and say that these transactions to B, C, and D are in one block, and the transaction to E is in another block, and also from D to E and C to E would be in that other block. So this is block 1, this is block 2. That's a simplistic way of looking at it. It's not entirely accurate, so I don't take it completely as a truth, but it's pretty accurate, a representation of the idea of it. And when we mine this block, we basically hash it. We give it a hash. Hashes are pretty common things. Bitcoin uses the CRC32 hash for proof of work, and it also uses that for hashing various things that are on the chain as well. And so what you would do is basically you take this spreadsheet and you would run a hash on it, and the hash is a smaller number, and every time you run it on that particular data, you end up with the same hash. So if you take this spreadsheet or block and you give it to 1,000 machines and they all hash it, they all get the same number. And so then they're able to agree, yes, we have the same data here because we all have the same hashes. But then that doesn't prevent the idea of changing a number in there somehow that you would get the same hash, for example. Although that's exceedingly difficult, it possibly could be done. So there's that as well. So what cryptocurrencies have introduced is a form of proof of work. And the proof of work serves to do two things. First, it serves to create new coin in a lot of cryptocurrencies. I don't know that's true of all of them, but in a lot of them it serves to create new coin. And it also serves to mine the blocks that secure. It's basically secure a block so that everyone can agree, yes, this is the block that this is the data in the block, and we all agree that it's the data in the block. And occasionally there'll be what's called a double spend event on Bitcoin, and that's where the blocks don't agree. And then there's a way to resolve those based on how many people think it's this version over this version. So in other words, you might have maybe this transaction missing from A to C in one block, and maybe like 10 miners think that that's the case because they picked up that copy of it. And so there's a way to resolve that, but that's just by random chance, not by intent. But with the proof of work, what happens is there is in Bitcoin especially, it uses this thing called CRC32, which is, again, just a hashing algorithm. And what they do is they try to hash a certain amount of data to the point where you get all zeros, basically. That's the answer, is all zeros. And that's called the nonce. And in Bitcoin, if you find the nonce, if you happen to pick the right seed for that particular hash period, and it's a period of time that everyone is hashing, and while they're hashing, they're also hashing and securing the coin. So you can imagine that they're sort of like creating their own seeds and then all working on the same problem, and then they're going to take that problem and encapsulate it in their encrypted or with their seed, their encrypted version of that. And if they end up getting all zeros, then they announce that to everybody, hey, I got all zeros when I calculated this, please calculate it and verify that I did. And then if everybody says, yeah, you did, then that person is issued, or what happens is a field value is updated in the graph that says this particular miner gets this coin, this new coin. So it's like a new field or line or row in a spreadsheet appears when the miner solves the problem, the nonce. So now that's a really simplistic view of it. There's obviously more to it. I didn't talk about how like the addresses work and things like that, but basically this address has some sort of crypto key associated with it, which the keys are then distributed and can be created on the fly. And that's changed a little bit over time, but it's pretty much the same way it was when it started. So any coin that's on the chain, like on the Bitcoin chain, can be used today just as easily as it could back then. So that's a sort of a loose way of explaining all of it. I haven't done a great job. There's much better explanations online, but that's my version of it, and probably slightly inaccurate in some places, but more or less gets you the idea of what's going on a chain. So for the Pi network, I have no idea what the proof of work is. So what we're going to do is we're going to go Pi coin proof of work. I'm just looking at that. Who knows if it's true or not. Here we go. Here's the proof of work. I don't know why it's on LinkedIn, but okay, whatever. Pi is not free money. How does it work? Instead of burning energy as proof of work, cryptocurrencies like Bitcoin does, Pi secures its ledger when members vouch for each other as trustworthy. This forms a network of interlocking security circles that determines who can execute transactions. This allows crypto mining on your phone by leveraging your existing social connections with no financial cost, no battery drain, and a light footprint on the planet. So a lot of people have said that maybe cryptocurrency is a Ponzi scheme. And I guess in a way it could be viewed as a Ponzi scheme. I mean, if you think about the idea of putting a value in here and then securing it with a bunch of people validating it, then that's just everybody that's running the miners agreeing that this value is this value. And that by doing that, that provides some level of security I always talk about, when I talk about cryptocurrency, especially when I used to get up and speak about it, um, there are these things called the Yap Coins. So it's these giant stone coins. And so the story is that on the island of Yap, they don't have this. This stone does not exist on the island of Yap. I mean, they do. The stones are there, but people have brought them there. And then back in the day, this was hundreds of years ago, they would go to a nearby island. It wasn't super close. They had to build dugout canoes and then row or sail there. And the canoes had to be able to carry these things back, obviously. So they were pretty big canoes. And so it was a lot of work to build the canoes. And then when they got there, the people that lived on the island where they were mining these coins, you can see the similarity here already emerging, is they were violent. They were savages. That's what they called them, savages. The Japanese, or the race stones by the Yap. So the Yap was like 5 islands, but they were, for a long time, I don't know if they are anymore, but they were a matriarchal society. So the women were in charge, or sort of in charge. It was kind of a shared thing, but the men were responsible for doing dangerous shit, and then the women ran things. And so the men would go off in their built canoes. They'd build the canoes, and they'd go off, and then they'd mine these coins out of the cliffs of this island where these people tried to kill them. So it was a risky business. So the whole idea is there was a limited supply, and it wasn't artificially limited. In other words, it wasn't like some agreement they all came to. It was just like real world conditions said, can't make very many of these coins. So there's a limited supply of coin coming into the system. So we kind of have that with Bitcoin. When you mine Bitcoin, there's like a limited supply coming in because that nonce is hard to solve. That puzzle is hard to solve. And in order to solve it, you need to risk. You need to buy machines, and you need to get power. You need to join a consortium of miners, like a mining pool. You need to cooperate with them. So there was cooperation here. You couldn't go to an island by yourself. You had to go with other people. And then whenever they managed to get the coins, the race stones back, then what happened is they had to remember whose coin was whose, because you can see here they just kind of lined them up. And the purpose of lining them up was like, okay, well, this is the bank, and then we're just going to memorize whose coin is whose. And the bigger coins, because they were harder to get there, were worth more. And so they would pay for all sorts of things. They'd pay for weddings with them. They would pay for livestock and food and land. They used them as a money. And that's a very sophisticated idea, and that's why it's so cool, and why I use it as that idea is that it's something that is sort of innovative and modern in a very real way that was happening hundreds of years ago. And it was simply because this was a limited resource. And if you think about it, like diamonds have been used because it's hard to get diamonds. But then a lot of times you get this corner on the market, and maybe some coins, some crypto coins, allow the market to be cornered, if you will. And I don't know about all of the different crypto coins. There have been a lot of them, but I can, in general, say one thing that I can say is that a fiat currency, let's look up fiat currency here. So fiat money. So fiat money is just a thing that we all agree on that we're going to use for exchanging value of real world items, like a stone that somebody had to go mine. So if this was a nice marble stone, I might want to put it in my kitchen, for example, on my countertop. And that's worth something to me. And compared to like what the supply is and how it is delivered and installed and the value that it gives me long term, like it's not going to dissolve. A nice marble stone countertop is not going to dissolve over the years. It's going to last, and it's going to preserve, and it's going to become more valuable over time, presumably. Then there's some value to that then you can say, how does something that's not really valuable, a piece of paper with a person's head on it, how does that retain value over time? And the answer is it doesn't. There's such thing as an inflation in the economy. And so how do you prevent inflation? how do you prevent that little token of value from inflating? And here with the ray stones, it's because the supply was limited. So yeah, you could continue to mine them, so people would continue to go get them, but over time it became, it's a hard thing to do, and it's not, it doesn't get any easier. Let's put it that way. And there was even an episode where someone dropped one over the side of the boat as they were coming back to the island, to the Yap Island they were living on, and it fell in the water, and it was like 20 feet of water. So what happened is all the men swam out, and they dove down, and they verified it was there, and then they recorded that in their remembering of who owned what stone. And that was their version of the chain, or the blocks. They memorized all the transactions, and they did this while smoking some sort of variety of like hallucinogen, and drinking some fermented drink that they made on the islands. So that was their part of their job, which sounds pretty good to me, actually. And so having a beach and drinking and memorizing who owns what, it sounds perfect. But so in fiat currency, we just all trust that. And so if you think about it, at the end of the day, you can create as many cells in a spreadsheet or as many rows in a spreadsheet as you want to, but it's only if everyone agrees that that particular cell is worth something that it makes it work. At the end of the day, we're all people, and while you might be able to automate some of this once everybody agrees, if everyone doesn't agree that it's worth something, then it's not worth anything. And if everyone agrees it's worth something, then it's worth a lot. And I think that is reflected in the price of Bitcoin, especially recently. And I've worried about it before, about whether or not it's a wise thing for us to all put our minds to something that is not really substantial, not a real thing, if you will. It's just a bit on a drive somewhere. And yeah, it's on a whole bunch of drives, but I don't know that it's, I mean, we can illustrate that bit, though, or those bits or bytes got there, gigabytes got there by someone exerting a lot of work in the real world, burning a lot of energy to get it there, and buying a lot of equipment and installing it, and doing the work needed to get it there. But by decoupling it from a real world object like a piece of paper, or in this case, stones, I don't know that it's a great strategy long term, but we're going to find out real quick, I guess. And I think that at the end of the day, if you look at a particular coin, the proof of work is the thing that really determines whether or not people end up trusting it. And if you can get people to trust it, and it is trustworthy in and of itself, in other words, I can't quickly write code like people have done for Ethereum, for example. I can't quickly write code that then takes someone else's coin, then people will trust that it's useful. But I don't know that an unlimited supply of coin, or if you will, fields in a spreadsheet in an infinite number of coins, is going to be something that people put their trust in. So it becomes a marketing problem at that point. Bitcoin is sort of beyond the marketing problem now, with it being worth $60,000 today a coin. I can't believe that. I can't even believe I'm saying that. But someday it'll be worth $600,000 a coin, and beyond that perhaps. But if we survive that long, it is a thing that people are starting to put their trust in a way that becomes like groupthink, if you will. It's a assumed thing. It's kind of like, where does the Earth's magnetic field come from? Most people think it's the iron in the Earth creates the magnetic field, and because it's spinning, and because of the sun, maybe. And so, but the reality is sometimes we actually don't know the real answers. We just all have a common belief. And if our common belief is that Bitcoin, which is something that we can attach the common belief to, a word we can attach it to, if we all believe that that's worth something, then it'll continue to be worth something. But if we don't, then it's just a bunch of bits or bytes on a hard drive somewhere that somebody spent an awful lot of time on, and it's in and of itself is not worth anything. It's worthless. I mean, I can make a copy of it. To change it is costly because of the way it's set up, but that's only because of the consensus that has occurred. If everyone stopped mining and I was given a quantum machine, I could probably start changing the blockchain as I needed to for my own benefit. And especially if everybody stopped mining, then I would have the only chain. So all I'd have to do is crack the crypto keys for each of the fields, and I could have as much Bitcoin as I wanted to, assuming I had a machine that could do that. And so it is only by all of us together thinking and believing and continuing to work on this idea of Bitcoin that makes it possible for us to continue to use it. It's basically a means of providing consensus by people's beliefs in whether or not something is secure or not. And in the case of Raystones, the people there believed it was secure because they saw it work. And as long as you see something working and people aren't having that conversation, or even if they are, somebody raises the question, well, why the hell are we doing, getting these stones? That little stone over there, I mean, I think somebody chipped around on it and now it's this stone over here and nobody can remember whose it is. If that happens a lot, then that erodes the trust of the coin. And in the case of this, where'd it go? Pi coin. I don't know. I don't know about it. It might be that it's a good idea, and it might be that it's a bad idea. But what you can do is you can take that coin as you're mining it. If you choose this as your coin to mine, you can mine it, and then you can transfer the value on an exchange into something you do believe in, or more people believe in, and that's Bitcoin. And Bitcoin's the gold standard. And so that's why I took all my Doge at some point in time when it was not worth much and sent it over to Bitcoin. And I didn't get a lot for it. And maybe I sold all of it. I don't remember. And anyway, that's the story, and I'm sticking to it. And I hope this was useful. You have a good one. Take care. Bye.